Ultra-high molecular weight polyethylene. What is ultra-high molecular weight polyethylene? It is one of the world's highest strength plastics and one of the best plastics for engineering. Ultra-high molecular weight polyethylene is a type of polyethylene with incredibly long polymer chains, millions of daltons in length. These incredibly long chains give it the material its strength. Ultra-high molecular weight polyethylene is unique in that it has a number of good qualities, including very high impact strength. It's one of the highest of any thermoplastic. It has excellent abrasion and wear resistance, ideal for sliding surfaces like gears and machine parts. A low coefficient of friction, once again useful in things like gears. It has a low temperature resistance, good for like freezing applications. It does not have a high temperature resistance. It does melt, but it is also chemical resistant. It resists most acids, bases, and solvents. It has a low density, making it relatively light, and it can even float on water. It has antimicrobial properties, good for bioengineering and food-related applications. And it also has a low water absorption, meaning it absorbs almost no water at all. What is ultra-high molecular weight polyethylene useful in? It's useful in applications where durability is needed, like gears, outdoor furniture, high-strength rope, joint replacement, and body armor. More on that later. How is ultra-high molecular weight polyethylene made? It's made in a number of processes, such as the sheet press, billet, and ram extruding. Sheet pressing. So this process is used in a more of a mass production type scenario. It starts off with a powder, a uniform powder that is spread out along the sheet press surface that is then heated and melted, and once it's brought to the melting point, it will fuse together in a process called sintering. The material is then pressed under high pressure with a hydraulic press, compacting it into a solid uniform sheet. It is then moved on to the cooling press, where it cools to prevent internal stresses, cracks, and warping. And once it's moved off the cooling press, it's on the prep table, where it is then trimmed and the rough edges are taken off. The billeting or extrusion process is kind of similar. It once again starts with a powder that is melted in an airtight chamber, where the powder once again sinters together and is then extruded through a tube. This produces, instead of a sheet, more of a tube, cylindrical type thing, where is once again taken off, cut, and cooled. The ram extrusion, once again, a very similar process where powder is loaded in, it's airtight, the powder is heated, it fuses together, and it is extruded and then cooled. This process is a little different because it uses a hydraulic ram that pushes the softened ultra high molecular polyethylene out of it, and it is then put into a shaping die where the material is forced through the die that forms rods, tubes, or other custom shapes that might be needed. It is once again then cooled and cut to length. Some products that are made with ultra high molecular weight polyethylene are outdoor tables where the weather resistance, abrasion resistance, and chemicals resistance is very needed for that outdoor durability. Machine parts like gears, sprockets, and chains and guides and things like that. The low friction prevents wear on it, and also the plastic has a kind of lubrication property that prevents wear with long-term use. It's used in things like climbing ropes for its strength, and body armor, once again, for its impact resistance. One interesting thing that's used in is things like this. This is a hip joint for a hip replacement surgery. The ultra high molecular weight polyethylene has a good biomedical application where it's actually absorbed into the body and it's not rejected, which is good for joint implants, and it should last until you die, hopefully. Sources. Thank you.